Hello everyone! In this presentation, definition of alerts and their reliability associated with the times Ames mutagenicity model predictions will be demonstrated. For the purpose of this demonstration, a chemical which is predicted to be Ames positive due to identification of alerts in the simulated in vitro rat liver S9 metabolites will be exemplified. As shown in another video, the metabolites containing the alerts for DNA interactions are highlighted by default. Let's now analyze the structural boundaries which are applied on the predicted chemical. Alerts are structural functionalities associated with positive predictions. The alerts include structural boundaries which are expertly derived and validated by their application on the training set chemicals in the model. Usually, more than one structural boundary is associated with one alert. However, all boundaries address the same molecular interaction mechanisms. The structural boundaries which are defined in the first query are visualized by default. The query which is matched on the predicted target chemical or its metabolites is marked with green tick. Definition of the alert is described in the right half of the screen. In this case, the defined fragments could be attached in the highlighted position. Additional fragments from other parts of the molecule which could reduce the mutagenicity effect are also introduced to complete definition of most alerts. All alerts in the model are associated with mechanistic justification of the possible interaction with DNA. In this particular case, we have multiple mechanisms associated with the reactivity of the chemicals captured by this alert. The structural boundaries of the alert are sequentially described in the mechanistic justification where all chemical reactions are supported by literature sources. Only alerts with clear mechanistic justification are included in the model. Let's go back to the chemicals captured by the alert boundaries. They are provided in a separate window. Those are so-called local training set chemicals. As the name implies, this is a fraction of chemicals from the entire training set of the model captured by the alert. A scene visualization of those chemicals is shown in grid distribution, where the structures are well depicted. In another mode, one could see the same list of chemicals organized as CAS, chemical name, SMILES, experimental Ames data, and model predictions. Proprietary chemicals are not included in this chemical list. The chemicals from the local training set which are captured by the same alert boundaries as the target chemical are highlighted in red, indicating they are the closest analogues of the target. Analyzing the highlighted analogues, one could see whether the alert is applied on the parent chemical or its metabolites. Let's take, for example, the target chemical. As seen, the parent compound does not belong to definition of this alert. However, it has a metabolite which is captured by the alert boundaries. In another chemical, which is also highlighted, the parent compound is directly captured by the alert boundaries and there is no indication for reactive metabolites. Each alert is supported by reliability estimates. For those estimates, non-proprietary and proprietary chemicals are taken into account. Alert performance is the ratio between correctly predicted positive chemicals over the total number of positive chemicals captured by the alert. Estimated alert performance, confidence range, and p-value are also visualized and depicted. As seen, estimation of the alert performance differs from the performance of the sampling alert performance. It accounts for the possibility true alert performance to deviate from the limited size of the sample. The smaller is the sample, more distinct is the estimation from the sampling alert performance. The bigger is the size of the local training set, the narrower are the confidence ranges, and vice versa. Narrow confidence range corresponds to reliable prediction. In turn, P-values indicate for probability of performance equal or better than the performance of the alert to be achieved by chance if drawing chemicals randomly from the training set.
One could see a blue line indicating for the performance of so-called naive alert.
It represents distribution of positive and negative chemicals in the entire training set of the model.
Reliable alerts should have much higher performance than the naive alert.
In fact, high reliability alerts in the model should have high alert performance, narrow confidence range, and low p-values. Details on the reliability estimates is provided in a separate section of the model called QSR Model Reporting Format. Here, along with different information associated with the model, also showing the main characteristics of the DNA binding alerts, internal and external validation of the model, as much as other many details, mathematical formalism underlying the above statistical measures are provided as a supporting material. Here one could see also different examples. Thank you so much for watching this video. If you're interested in TIMES, please contact us in the links provided below.